Hello, and welcome to the channel. Thank you for joining me again. Small, well, I'll say a small update. Quite a lot in this update, but still quite small progress. As you can see here, I've taken the driver's seat out of the Micra. That's for two reasons. The main one is that the left-hand side seatbelt lower mounting bolt here has a spreader bar on the back of it, which means I have to go through this hole to hold it in place in order to tighten that nut up, and then to weld the plate on the back. There's a spreader plate on the back of the back of that hole. The problem being is that this bracket here, or this hole here with the seat bolt, used to be where the harness mounted, or the seat belt mounted, the original seat belt. The problem with that is that the seat brackets that I have don't allow you to put anything behind them. So and it's not in line with this one on this side here, which is again on its own as a seat belt mount. That's the seat mount there. So this one here now lines up perfectly with that one on that side, and you've got equal pull on the lap strap for the harness on both sides. So I've taken the seat out to do that, and I've also taken the seat out to clear up all the crap that's in the bottom of the footwells before I paint it again. This bar here, this strengthening bar, I may or may not take that out, and then obviously mount the seat directly to the floor. The issue being at the minute, the best place for weight distribution and driving position would be to have the seat mounted to the floor and then a pedal box mounted in the footwell. The problem with that is because of the quite high dashboard on a Micra, I and my gravitationally challenged self wouldn't be able to see over the bonnet. So I will probably retain the seat in its current location until I can decide what I'm going to do as far as homologated seats and harnesses go, for if I do go for a championship of some kind, or a day where it needs to scrutineer. The other things I've done, you can see there, you can now see the floor through where the fuel tank was. The fuel tank has been taken out, which was actually a 10-minute job, which I was surprised at how easy the fuel tank came out. There's a couple of pipes, the filler neck, and 2 bolts, and the thing fell on the floor. So yeah, it was really easy to get the fuel tank out. The difficult part was moving it, because I'd forgotten when I last ran the car and blew it up, I'd actually put 3/4 of a tank in it. So it's pretty much a full tank of fuel at the minute. So with that, it was difficult to move it, but I've taped up all the orifices, given a little breather on one of them, so they're not completely sealed. It's the tank can still breathe, but I've sealed up most of the big holes with bags and tape, and put it outside behind the garage so that it doesn't fill any confined spaces with fuel vapors, which would be really bad, especially when welding and grinding. So that's out of the way and safe, and away from anybody that might go near it. And for the time being, I don't think that fuel tank is going back in. And the reason I say that is because the fuel tank itself has all of the return lines and anti-tip and the vent lines and everything like that running from the tank, the big plastic tank. And it's already in quite a low position, which again is good for centre of gravity, not so good for a low pressure carburetor fuel pump, where you need the pump lower than the fuel level. Now, to achieve that, you would ideally have a fuel tank above the fuel pump, which then uses the gravity feed into the pump to push the fuel into the engine. The pumps don't create pressure, they create flow, and the pressure that is created is the restriction to that flow. With that, a low pressure pump creates very little flow. What it also doesn't have is the ability to suck fuel out of a system. It needs to be fed fuel at a steady rate under gravity, and then it flows that fuel down the fuel lines to the carburetors. through a fuel filter and everything. Again, what I said previous was that I may end up having a fuel cell in the spare wheel well and a swirl pot set up. So I'd need a lift pump out of the fuel tank into a swirl pot, and then mount the pump for the carburetors below the swirl pot, which would create head pressure for the fuel system. At the moment, that's all on hold because, again, I'm not 100% certain which way I'm going to go for the fuel system yet. I have been asking around about putting the motorcycle fuel tank, the Kawasaki ZX9R fuel tank, in the front footwell on the passenger side there, with the fuel pressure regulator and the fuel pump sat underneath it, so that it has pretty much the same setup as it would be in the bike, only it's not sat on top of the engine, it's sat in the passenger compartment. A few of the comments I've had is, I wouldn't want to have a fuel tank sat next to me in the car. Okay, fair enough. The other one was, isn't it in a confined space? Well, the two answers I have for that for you is A, yes, it's in a confined space, but it doesn't breathe or gas off fuel, so there'd be no vapours coming from it. Any overspill would be directed through the filler neck of the fuel tank into an overflow pipe that would drain under the car, much like it would do on a bike, but instead of going through the frame of the bike, it drops under the chassis of the car. The other one was, well, I wouldn't want a fuel tank sat next to me in the car. Well, I'd rather it be inside a car with a roll cage round it than laying on top of it on a 200-mile-an-hour motorbike. So, you know, as far as safety margins go, the fuel tank itself is double-skinned, which is what's required for fuel tanks inside cabins in rally cars, race cars, and everything for the MSA and FIA licenses. I'm being joined by my daughter there. So yeah, with that, they're double skinned. So you've got a plastic bag or a plastic shell inside a metal case, which is ideal for a fuel cell. Now the drawback is the capacity and the mounting system. How do you mount it, and how do you get enough capacity to drive a car any kind of distance? Again, that's not going to be an issue if it's on track days. You would take with you jerry cans and refill the tank as and when you needed to. It would still be good for a good 50-60 miles, which is quite a few laps. I reckon the brake discs and pads would overheat long before you ran out of fuel. So those are the options at the moment: the motorcycle fuel tank or a fuel cell in the boot. Probably, to be honest, with ease of access and the fact that there's already a hole there for one, I'd probably stick it in the boot and then run the fuel pipes through the floor down here, and then connect to the original fuel pipes up here, and which go up to the engine bay there. They're already routed, so there's no drama with actually connecting up to them. It's just rubber hoses on the end of the metal pipes there. I did check underneath, and the only piece of rot I can find on the chassis is here. Hello, darling. Is here. There's two holes underneath where the back seat was, and there's a piece of sound deadening there, which I chipped off, and there's two holes. I've used some of the big cut-off that I used for the bonnet for the aero catches, placed that on top of the holes, and then tack welded it around. I'm going to go underneath and put a plate underneath each one of these, and then sort of sandwich it with fiberglass and paint. Basically, it's non-structural. It is simply there to stop water from coming in the car. So the reason I dropped the fuel tank down was so I could tack those in, because the fuel tank butted right up against that surface there. With there being no fuel tank there now, that's not going to be an issue with me welding it, and I can go underneath and repair it from underneath as well. They were the holes were there because water has got in at some point, and that's the lowest point of this seat rail here, and it seeped underneath the sound deadening and created a sandwich between the sound deadening and the paintwork, and it's just rotted through. So that's the only piece of rust I found. I've gone under the car and poked and prodded at all the usual places, and it's all completely solid and rot free, which is a bonus. The other thing I've done, the roll cage over here, I don't know if you can see all the shit stains on the paintwork there. That's me welding in one of the roll cage feet. I know I said I was going to get somebody else to do that, but at the end of the day, it's metal, and if I don't try, I'm never going to learn. So I drilled the holes out for the bolts to go through and the captured nuts to sit into. So there's little pockets in the chassis for the captured nuts to drop into, which then lines up the roll cage. And the way I got that mount lined up there was to put this one in with and line it up as best I can with the chassis, so that it fits snugly on the sill to seat pan area, and then bolt that one in, and then I'll drill a hole through the side and put a bolt through to line it up, and then line this side up here and measure it from the back rail of the car here, and then the front edge of the seat pan to make sure that it was good forwards and backwards, and then measured it left and right at the main hoop here to the B pillar. So it's now square, it's in the car. It does move a little bit because I've not tightened the bolts up yet. And what I'm going to need to do as well is there are some holes where it's blown through the arch. So I am going to have to keep tacking around that area until the holes have disappeared, and then grind it back so it's nice and smooth and ready to go. The other issue is, as well, is where the old battery tray was, and there are some holes which need filling, and there's also some holes. I don't know if you can see there. That is a hole where the previous owner has punched through the chassis with a cold chisel in order to get inside the chassis rails to spray wax oil in there to stop it from rotting, which I thank him for very much. Gives me a good strong shell. The two drawbacks of that is it's now filled with wax oil, and wax oil doesn't like welding very much. It does tend to set on fire. And there's now bloody great holes in the chassis, which I now have to fill. So that's a problem that's on both sides of the chassis rails there in the boot area, and I will have to patch them up. I have also started on the front left here. I marked these areas out just there. I marked these areas out for the position of the roll cage feet when I had the roll cage in the car. And obviously that piece at the back there has been put in while the roll cage was in one piece. I've since taken it apart for ease of access for him to get in and out of the car because the door bars were on, and I tended to smack my head on the bar going across the front there. So what have I done over there? I've drilled 2 holes in the chassis. Let me zoom in a bit. I've drilled 2 holes, and those holes are what allow the captured nuts to drop inside the chassis, and then the foot there, which is laid on the floor, hooks into those holes or recesses, and then the plating actually butts up nicely to the sill, so that it can be welded all the way around. I haven't done the other sides yet, but I have marked them out. You can see one down there. That one's been marked out there as well, but it doesn't have the foot under it yet. And that one's been marked out. Again, it is very, very tight, as it should be, and I'm putting a slight bit of positive load into the roll cage, so it's actively pushing the chassis outwards rather than being bolted and tensioned into the chassis, so that it's under positive pressure. It's the roll cage itself holding itself in rather than the bolts holding the roll cage to the chassis, if that makes any sense at all. While my daughter's driving around a Mercedes SLK around the garden, doing a very good job at it as well. Not crashed yet, which is good. What else have I done? Well, I received a delivery of this baby. Now, I've had a few people asking me about how are you going to connect the chain drive to a differential. Well, what we have here is the differential from a Mazda RX8. This is what cost me 20 quid. Bargain of the century. So it's a Mazda RX8 differential. You can see in there it's a limited slip differential with the spring plates in there. It's Takegi Fuji diff, I think they call it. It's a Fuji diff anyway. It's a unique way of having a torque sensing limited slip differential without having masses of gears or a viscous coupling in there or plates. The drawback to this is if you lift one wheel completely off the floor, so there's no torque going through it at all, it will revert to open and send all the power to the wheel with no grip. It's limited slip rather than no slip, so perfectly fine for this application and ideal for what I wanted. Now, what have I done so far? Well, the first thing I did was take all these bolts out, which are grade 12 bolts. They are very, 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 very high strength, high torque bolts. And it took an absolute age to get them out of the car, out of the diff, sorry. I had to have a 1/2 inch socket on here with a bar on the end of the 1/2 inch socket with a hammer on the end of the bar, and if you don't can see the marks on here where I've temporarily put the sprocket on to give it a bit of grip so I can hold it. It's torn the desk up completely, or torn my bench up completely as I'm trying to turn these bolts. And then I've gone through 2 battery packs on the impact driver, taking these bolts out. So they were bloody tight. But they're all out, no stripped threads, no damage done, perfectly fine. Then, what it came with is these taper roller bearings on there. Okay, so there's one on either side. Taper roller bearing this is the inner race here that sits onto the shaft. And then you have this cage which sits around the outside and a series of rollers kept in the cage, and then you have in the differential casing of the car you'll have a corresponding casing that fits over the top of that with a cage around the outside, or a race around the outside, which allows it to rotate and roll. Now, taper roller bearings take up both lateral and axial thrust. Is it lateral and axial? Anyway, it takes up thrust in this direction and some thrust in this direction as well, because of the angle of the bearings there. Now, in order to get these off, you have to crack them off. You have to crack the inner race in order to release it, and then they'll just fall off. This one, I managed to get the angle grinder in there at an angle, which is kind of poetic, really, isn't it? I got it in there at an angle. Didn't cut all the way through, but I cut enough through there to release the pressure off the inner race here, off the inner face, and it just lifted off, fell off. Piece of piss, that one. This one was a little bit more problematic because I couldn't get, if you have a look here, I couldn't get the angle grinder in here because it was nicking the side of the face. So there was no way of getting an angle grinder in there to get the position needed to take this off. So I used a flap wheel and flattened that edge. Oh, bloody focus you. There we go. Focus. There we go. So I took a flap wheel and flattened that side of the bearing off until it was very, very thin. And then that little silver bit there, sorry, focus. That little silver bit there, where my finger is, was done by my Dremel. And 2 seconds with the Dremel, and it cracked. You can see the crack there. It went with a big bang, and it flew off. Came off there, no problem at all. That's the bearings off. Now these bearings here, or the shaft, sorry, for tapered roller bearings is a different measurement to bearing blocks, which is what I'm going to be using to mount this. These, if I take my cheapy nasty digital verniers, it says 45.20. There we go, 45.23 is the measurement on there, and I've checked that by having a look at the the number on the end of the cage there, which is R45Z-5, which comes up as internal diameter 45.23 millimeters. Okay, so I've got the external diameter of this shaft, so I know the internal diameter of the bearings that I need? No. Not quite as simple as that. Taper roller bearings have a different measurement to other bearings, which means that this dimension on the outside of here is 0.23 of a millimetre too big. You cannot buy or specify or order bearing blocks or any other kind of normal roller bearing in 45.23 millimetre internal diameter. I've checked, I've asked the manufacturers, I emailed SKF, they don't make one. They just don't exist. There's no imperial equivalent. It just doesn't happen. So what I'm going to have to do is send this to an engineering shop and have these shafts, these axle outer diameters, turned down in diameter by 0.23 of a millimetre, which is not a lot. It's probably going to take them about 5 seconds. But that takes this outer diameter here down to the correct size so that I can fit a bearing block onto there, which will then hold the differential in this orientation here, like so. And then the bearing blocks, once they're in with the 2 bolts at the bottom, you can then build a cage for it and then mount this in the car with a cage bolted to the engine and the firewall, and get some shafts made, which is easy because you use RX8 CVs out of this side with a little stub axle on them, and you use the Micra CVs on the outside with a stub axle on them, and then join them together in the middle. It's not going to have much torque going through it, so highly unlikely you break them if they're welded properly. But yeah, the other option, or the other problem I've got here, is the sprocket. Now, just a second, sweetie. Now, what we have on the back here is the sprocket is bolted through 2 of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 holes that's in the differential casing here. So you've got one here and one here which line up perfectly. These aren't the bolts that I'm going to be using either. These holes are too small in the sprocket, so they're going to get made bigger. The options I've got are scrap this sprocket and sell it, and buy one that's solid, of the same dimensions, so 520 pitch and 45 tooth in steel. They make a lot of them in duralanium or aluminium alloys or whatever you want to call it. They're just not going to be tough enough. They're going to wear out too quickly. And I don't want to be taking the diff out of the car every time the chain wears out. Or the sprocket wears out, sorry. So that's one option, is to order one in solid steel, 45 tooth, 520 pitch, and just drill the holes in and mount it that way. That's an easy way of doing it. The other way of doing it is, because these 2 holes line up, I have this perfectly centered on the differential here, and the other holes, there's 1, 2, 3, 4, which line up to empty space. And then there's 1, 2, 3, 4, which line up to correspond with the webbing on the sprocket, on this the sprocket here. What I can do is, because this is steel, again, take it to an engineering shop, get them to fill these areas here with 6mm plate. I think 6mm, might be 4mm, but get them to fill that with steel plate, then drill the holes in it and re-drill the holes, and then nut and bolt it straight through. So we'd probably use these ones through there from the other side, and then put some red Loctite and nylock nut, or some way of locking it on there pretty bloody tight, and then that would do it. That would be bolted together. How to seal the diff. Now, there's 2 options that have been shown to me. There's one guy that's running a similar type of differential in a Fiat Cinquecento with a ZX9R engine in it. He runs track days all the time, and he runs his diff open like this. No oil whatsoever, just runs it open. I've got another guy who built a tank to go around, or a cap to go around and sit just on this lip here with some sealant around it and a plug for oiling the inside of the differential filled it with diff grease or diff oil, and then put a cap on the end, and then put the bearing blocks on, so it's then a sealed diff. And I think I'm probably going to go that way. The other option, not really going to happen on this diff, is to weld plates into here and here, and then seal these holes up. 1, 2, 3, 4. I've done the other side. It's not particularly heavy, this thing. 1, 2, 3, 4. Seal those holes up, and then run it as it sits here, but fill it with grease first. So you'll end up, instead of having a cage around this will be the cage, and then you'll have a door on here with a port in it. That may be an option. It may not. It depends on how much it's going to cost to get it welded. So that's what I've done so far. Not a particular lot on the car itself. That's pretty much as it was the last time you saw it. But lots of other stuff behind the scenes with, like I say, the differential, getting the bearings off, which took a bloody age to do, and the fuel tank out. Roll cage is getting fitted or progressing to a certain degree, and yeah, that's where I sit at the minute. Now, if anyone's got any recommendations for machine shops, welders, whether they can recommend any kind of techniques or suppliers of parts or anything like that, please don't hesitate to contact me, either in the comment section below, or those that know me can do so on the Facebook page or Instagram, or through Patreon. Anything like that, you will get through to me, and I will be able to either answer your questions or respond to your suggestions. Thank you very much. Please like and subscribe the video and follow the build, and see you in the next video. Thank you very much.